And so when starting this one, of course, just pick two of the sets of parentheses and multiply those. I'm going to go ahead and just multiply the first two together. Now if you do it out the long way, you end up with x squared plus 2x plus x plus 2 in there. But of course I do want to simplify that so I don't have to multiply quite as many by this binomial here. And so when we simplify, you end up with x squared plus 3x plus 2. And that trinomial is multiplied by x plus 5. So again there, you're multiplying everything in the first parentheses by everything in the second parentheses. And so when you do that, remember to check and make sure that you've actually multiplied all of them through. So if I'm multiplying 3 terms by 2, I should end up with a total of 6 terms there. Pay special attention to what your results are at this point, because as you probably already started seeing, especially like on the WAMAP or something, these can be big problems, at least at times. If you make one little mistake up here somewhere, it's going to trickle down. You're going to end up having a tough time finding it. You probably have to redo the problem. It's a lot more work. Taking your time up front and just being really careful up front helps save you a lot of grief. And then from here, it's just a matter of combining the like terms. And our like terms in this case are the squareds and just the x's. So we should end up with a final answer of x cubed plus 8x squared plus 17x plus 10. So far this year, we've been graphing a number of different forms of equations. We graphed linear and exponential. Linear and absolute value. And then we did quadratics. So we're taking the degree of our polynomials up each time. And so it seems natural then to go into x cubed next. So we're going to be looking at the graph just of y equals x cubed, our parent function here. So to start with, I'm treating this just like any other brand new graph that I don't necessarily know what it's going to look like. And that is by just grabbing some points. So let's just grab a nice easy point to work with here at the start. What if x is 0? And I plug 0 in for x here. What's 0 cubed? 0, yeah. So that tells me that I have this point right here at 0, 0. Go ahead and plot that point. This is going to be called our starting point. No, it's not technically a vertex. You'll probably see why here in a little bit as we get further along. But it is at least what we would refer to as our starting point, which is always useful. It's a point of symmetry. It has a few little details like that. All right, next up, let's go over 1. So if I plug 1 in for x, what's 1 cubed? 1. And we have the point then at 1, 1. Rather uncreatively. In fact, all of our parent functions so far have started with these same 2 points, 0, 0, and 1, 1. It's always a matter of what happens after that, though. So let's see what happens after that. Let's plug in 2. What is 2 cubed? Sometimes our natural inclination is to think 2 cubed. I see a 2 and a 3 next to each other, and you start thinking 6, but of course it's not, right? Because 2 cubed is 2 times 2, which is 4, times 2, again, is 8. So that means we go over 2, and we're going to go up to 8. Now, so go ahead and plot that. All right, let's see what happens when x is 3 now. What's 3 cubed? 27, yes, because 3 times 3 times 3, that's 27. That's definitely off our graphing grid. And so we aren't going to be able to plot that one. So what I know so far then for my graph is I know that starting at 0 here, I go up, and I'm going up pretty darn steeply, in fact. But we don't know what's happening on the left-hand side. We saw with quadratics that the quadratics bounce back up. But there's other graphs where sometimes it'll basically level off, and other ones where it'll kind of flip around and start going down again. And we need to figure out which of these this particular one is. And so let's actually again grab a point. Let's plug in -1. So what's -1 cubed? Well, of course, -1 cubed means doing -1 times -1 times -1. So that would be 1 times -1, which is -1. Yes. Which, by the way, also shows us a little bit of the starting of what ends up actually being a rule that you can use. Anytime this exponent is odd, a negative number to an odd power will always be negative. So it keeps its negatives. Whereas if you do if you do a negative to an even power, it'll always be positive. The same thing happens when we plug in the negative 2. Negative 2 cubed will give me a negative 8. And so we plot those points at -1, -1, and -2, -8. And of course, -3 will give us -27 again. It'll be off our graphing grid again. And so we now have this much of our graph. And so at this point, we now need to know, how do we actually sketch in the graph nicely? Because it can be a little bit hard to tell what's happening. Because we can kind of see this and we can see this, but what's happening between them can look a little different. I mean, is it just basically going straight through or what? And so we want to take a closer look at that piece. So as we zoom in on that, if you were thinking of like taking, let's say we plugged in half for x. 1/2 cubed would actually give you 1/8. Notice that's a pretty small number. It'd be like down here. That starts telling us what this thing is doing as it comes in to 0. It's actually flattening out. It looks a lot like this sort of a thing. In fact, on the right side, it looks pretty much like our quadratics did. It's just that as we go to the left, it's going down again, right? And so this is how it's going to look as we're getting around 0. It actually does flatten out right here at 0. So it starts out fairly steep on the outside, but it gets totally flat, totally horizontal right at 0, and then steep outside of that. So the overall picture looks something like this. This is then our parent function for the cubics. And so all the cubic functions that we will be graphing in here are going to be variations on this same theme. And the nice part is that all those variations follow all the same rules that all of our other graphs and all of our other functions have. So when you take a look at this equation, we know how to graph it because the 4 does the same thing the 4 has always done. And the 1 does the same thing the 1 has always done. The only difference is that it's cubed, so we know it's going to be that shape that we just created. It's going to be that cubic function. So the 4 here. The 4 is inside with x, so we know it's moving it in the x direction. Which way does a -4 move it? Up, down, left, or right? Yep, moves it to the right. Minus always moves it to the right. But what about the -1 hanging on the end? Yep. It's got to be up and down because it's on the end, and yes, minus goes down. So our very first point is right 4, down 1. Nothing changed just because this thing's cubic in that regard. We still start at that same point. Now that we know where we start, we make the same graph that we just made for our parent function, which means that I'm going to go over 1, up 1, and then I'm going to go over 2 and up 8. Now make sure that when you count that one out, the over 2, up 8, that when you count up, you're doing it from that original point, your starting point, not just the last point, but the first point that we plotted. And then repeat the process on the left side where we go left 1, down 1, and left 2, down 8. And then once you have those points plotted, then go ahead and draw the graph that goes through it. Yes, we do need to extend the graph out to the edge of the graphing grid from those points. So you plot all the points that fit, and then the graph.